Hi everyone. So we just got to talking about the double angle formulas, and here are some examples of how they can be used. So here's the first one: write as a single trigonometric ratio. And what that means is we don't want it to have a sine and a cos or anything else. We just want it to be a sine or a cos, basically. And hopefully you can see from what we did above that if we say this here, these two are both theta, then we can write this as sine 2 theta, so like this, sine 50. You should find that those are equal. So that's just applying the rule we looked at above. Okay, second example, a little bit more complicated. 1 minus 2 cos squared pi over 6. Now, looking up here at our rules, you can see it sort of resembles this one. So how can we make it look like that and therefore get it into a form of a cos 2 theta? Well, if you think about it, you could realize that, in fact, if we make everything negative like this, we could write it like that, if you see what I mean. So multiplying this bracket out would give us the left hand side. Might want to just check that, and then you can see that by thinking of this as being the theta, we can write this as using the cos double angle formula, which we have here. We can write this as cos 2 theta. So simplifying it a bit, which can be very useful, cos 2 times pi over 6, which is cos of pi over 3. So that answers the question. So we can do another example, a different type of example, and we will say if cos A is minus 1/3 and A is obtuse, find cos 2A, sine A, sine 2A, and tan A. So we can actually find all of these things. So how do we do it? Well, using the double angle formula for cos, since we only have information about the cos for this one, let's just use, again, this middle one here, which only involves cos, so 2 cos squared theta minus 1. So in other words, this will be 2 cos squared A minus 1. And now we just substitute in what we know. It's 2 cos A is actually minus 1/3. So it's minus 1/3, that's cos A squared minus 1. If you remember, cos squared A is simply another way of saying cos A all squared. So if cos A is minus 1/3, we just need to square it, times it by 2, subtract 1, and we will get an exact value. Let's type that in. So negative, let's use brackets, negative 1/3 squared times 2 minus 1, minus 7/9. And notice we could have done this all without a calculator. I was being a bit lazy there. But with this type of question, they're always going to want you to to find the exact value using this type of method. That what you shouldn't do is go, oh, I'll just do inverse cos of minus a third on my calculator and then double it and type it in cos again, because that won't give you an exact value. It won't give you a fraction, it'll give you a decimal probably. And anyway, this type of thing is more likely to come up on a non-calculator paper, so you need to use these techniques that we're talking about. Okay, sine A. Okay, interesting. Remember that sine from the previous video, sine squared plus cos squared equals 1. So therefore, let's just write this on the side. Sine squared A equals 1 minus cos squared A. And then we could square root both sides and say sine A is root 1 minus cos squared A. So we could say that sine A is root 1 minus, in this case, minus a third squared. That's just cos A squared. So let's type that in. 1 minus bracket negative 1 over 3 squared, and that's 8 over 9. So it's the plus or minus root of 8 over 9. And okay, so we got there. And the thing we have to be careful of now is it the plus or is it the minus? That's the question. You've got to be careful here, because sine could come out positive or negative. So here we have to remember this diagram of the unit circle. We were told that the angle was obtuse, so we're in this quadrant here because the angle is obtuse. Now sine, remember, is the height, so we can see that sine is always going to be positive in that quadrant because it's above the axis. If we were in this quadrant, sine would be negative. So we know to take the positive square root here. So it's going to be root 8 over 9. And if we square root the top and bottom, it's root 8 over 3. That should be the right answer. So remember, another way of thinking about this diagram is, do you remember we did this thing? I think of it this way around, as cast, the word cast. So it tells you that all the trig ratios, sine, cos and tan, are all positive in this quadrant. Sine is positive in this quadrant, but the rest are negative. Tan's positive in the third quadrant, but the rest are negative. And cos is positive in the fourth quadrant, but the rest are negative. So just taking this one for example, sine is positive, we know, because it's the height. But cos is negative because it goes to the left of the axis. And tan is also negative because tan is sine over cos, and if one of them's negative, the other's negative. So the cast diagram is often useful for that type of thing. Anyway, so we finished that one, being a bit careful with it. Now sine of 2a, we can use the double angle formula, 2 sine a cos a from previously. And we can simply substitute in what we now know. So 2 sine a is root 8 over 3, and cos a is negative 1 over 3. We can just put those all together. You can see it would just be, those would come together and make 9, and there'd be a 2 on the top, so it'd be 2 over 9 root 8. And actually there's a negative here, a negative sign, and that's possible for sine to be negative because it's sine of double the angle, which would take us into the third quadrant here because the angle's being doubled, so that makes sense. Okay, now tan a, if you remember, is sine a over cos a, so we can do that one easily because we already know sine a is root 8 over 3. Divide it by cos A, which we know is minus 1 over 3. GCSE, division of fractions, we flip the second one round. Root 8 over 3 times by 3 over 1, which just means they cancel. It's just negative root 3. So that should be correct for that one. So you'll get some practice on these in your homework. So let's do a third type of question, and that's going to be getting a bit more algebraic. We're going to solve, let's do it in radians since we need to get kind of used to that. Solve between 0 and 2 pi. Sine 2 theta equals cos theta. Be our first one. Our second one can be cos 2 theta equals sine theta. Right, looks a bit scary. So hopefully by now you should have realised, I'm just going to say this to make it doubly clear, but if there's a 2 theta anywhere, that 2 theta is locked inside the sine. You can't do anything, so you definitely can't like think of it as a doubling. You can't like halve both sides and say, oh, therefore sine theta is half cos theta. It doesn't work like that at all. It's non-linear. It's not like that's multiplying and you can get it out. You can only work with this using the double angle formulas, so we won't do that. If the 2 is on the outside, of course, you could do exactly what I just said, but if it's on the inside, it's much more complicated. So we're going to use the double angle formula. Sine, so we got 2 sine theta cos theta as another way of writing the left-hand side equals cos theta. Okay, here's another really important point. You might think here, oh, I'll just cancel those 2 cos thetas. Seem like a reasonable thing to do. The problem is if you do that, you actually lose solutions. So you miss out on finding out about what cos theta is. So on this particular with trig, don't cancel. There's a better way. What we do is we factorize instead. So try and remember that, otherwise you will miss out on marks. So what we'll do is we'll take everything to the left hand side and then we'll factorize out for cos. 2 sine theta minus 1. And now we've got one of those situations where there's 2 things being multiplied together and the answer is 0, so we can legitimately say that one of them must be 0. So cos theta equals 0, or 2 sine theta minus 1 equals 0. And then we solve them both separately. So, let's see if we can do it in this space here. If cos theta equals 0, that's cos, and then we've got those 2 solutions there. So put your calculator into radians. Inverse cos of 0, half pi. So theta equals half pi. Second solution, you remember what it is. Take it off 2 pi. You get 3 over 2 pi. So 2 solutions there. Don't forget we've still got 2 more to do. This one. Rearranging that, we can say sine theta equals a half. Put the 1 across, divide by 2. Sine theta is a half. That means we're expecting 2 solutions. Get the first one. I think we should already know this one. It's 1/6 pi, it's a familiar one. Second one, 180 minus, or in this case, pi minus a sixth pi, which is 5/6 pi. So we get those solutions, putting them together, that's the answer to the question. So we should really write them out, in a long line. Let's just do that. Theta is 6 pi, half pi, 5/6 pi, 3/2 pi. That's your answer. Okay, cool. So let's do the last one here. Similar idea. This time we're going to use the cos double angle formula. So what do you think would be the most sensible one to use? Because there's three options, aren't there? Let's just go and quickly look at them. Where's it gone? Here. Three options. Well, I would say let's use the third one, because then everything will be in terms of sine, and it's better to have your trigonometry equations in terms of one thing than in terms of two things. That means you're more likely to be able to solve them. So cos 2 theta, I've already forgotten what it is. Cos 2 theta, 1 minus 2 sine squared theta. 1 minus 2 sine squared theta. 1 minus 2 sine squared theta. That's the left side. Right side is sine theta. Okay, so who can guess what this is going to be like? See if you can have a guess. Yes, if you thought disguised quadratic, then you're right. So let's put everything onto the right side. We will get 2 sine squared theta plus sine theta minus 1 equals 0. You see there we've got a quadratic. We can make a substitution if we want, if we feel more comfortable. 2y squared plus y minus 1 equals 0. Factorize. Now what will that be? To make that minus 1, I need a plus 1 and a minus 1. If I put my plus 1 here, I'll get 2y minus 1y. That will give me the y. That will give me, yeah, so that's it. So this tells us either this one's 0 or this one's 0. So 2y minus 1, in other words, 2 sine theta minus 1 equals 0. Sine theta equals a half. Or sine theta equals negative 1. Sine theta equals a half. Didn't we just do that earlier? I think we did. Sine theta is a half. We came up with 1/6 pi and 5/6 pi. So let's just use that here. (5/6 pi). And for the negative 1, you can actually see the only place where sine is negative 1 is 3/4 of the way through. That's 2 pi, isn't it? That's pi. That's pi over 2. So it's going to be pi over 2 times 3. So 3/2 pi. So 3/2 pi. And that should be all the solutions. So yeah, just going back to this previous one, just look at what would have happened if we had done that cancelling thing. We would have ended up with 2 sine theta equals 1, and we would have ended up with just this part, which would have meant we only got these two solutions, and we'd lose out on the cos theta equals 0 solutions, because we would have cancelled out cos, so we would have dropped at least a mark or two. But I think I was going to say something else to you. Oh yeah, that's right. Final thing. These techniques are for if you don't have your calculator, you're on a non-calculator paper, or if it says you must show all your working or something like that. But if you're on the calculator paper and it asks you to solve something like this, and it doesn't tell you, you must use algebra or something like that, you can do it directly on your calculator. So unfortunately I can't share my screen of the calculator, but similar to last time, you want to be getting really good at doing all this stuff on your calculator, because on the calculator paper you save loads of time. It's really kind of a stupid idea to do it this long way if you're on the calculator paper. So just as an example, cos 2 theta equals sine theta. What you'd want to do on your calculator is go to graph mode, and please try this now. So you get your y1, is it y1 or whatever, the bit where you type in your graph, and you put cos 2 theta. You get your y2 and you put sine theta. You graph it, and you'll get, if you set up your view window correctly, which you'll need to do. If you can't work out how to do that, just ask me. You should get this kind of graph of cos 2 theta, which should look like that, and you should get a graph of sine theta as well. And the places where they're equal is here, here, and here, so 3 solutions. And that does actually make sense with us finding 3 solutions. And what you want to do is do gsolve and then do intersection, and you should be able to scroll through those 3 solutions and write them all down. And that's what you'll do for solving trig equations if you've got your graphics calculator with you. So have a go at doing both of those with the graphics calculator, just to check you can do it, because it's incredibly important to be able to do that. But yeah, that's it for this video, so I will see you next time. Cheers, bye bye.